Good evening, guys. So this video is gonna help you guys with doing these mole ratios practice problems. I know for a lot of you guys that were in class, you guys should be set to go. Even a lot of you guys finished with the worksheet, so kudos to you guys. Way to go. So this kind of serves as a reminder for those that were in class, and it's going to serve as a vital resource for those that were not present in class because of testing. Okay, so bear with me. We'll go through this step by step. Please pause the video anytime you need to kind of ingest any information that you learned. And if you have any questions, please come see me during school, and hopefully I can help you out. All right. So in these questions, we want to be using the information that's given, especially um, in our uh, balanced equation. Okay, the balanced equation is what's going to help us develop mole ratios. Okay, so we need a balanced equation in order for us to develop mole ratios. Okay, so we need ratios. Whoops, we need this. Okay, we need. So we look at our equation here: 5 moles of carbon plus 2 moles of sulfur dioxide gives us or reacts in order to produce carbon disulfide and 4 moles of carbon monoxide. Okay, so to me it seems like this is already balanced. Here we have 5 carbons, here we have 5 carbons, here we have 2 sulfurs, 4 oxygens, 4 oxygens. It looks like we're set. Okay, so when we're doing these problems, we have to follow a certain stepwise procedure. Okay, so the first step that we should consider is to circle the unknown, or what we're looking for, what we are looking for. Okay, sorry, go crumped up right there. So we want to circle that. So what are we looking for? Here we are looking for moles of CS2. Okay, that's what we're looking for. And then what we want to do is we want to underline what's given. Okay, so we want to underline what's given. And if we read our problem statement here, how many moles of carbon disulfide form when 2.7 moles of carbon reacts? The value that is given in the problem is always going to be what's given. Okay, so whenever you see a value such as this, that is always going to be what's given. Okay, so that's step one. Step one is completed. Okay, so let's keep going. So what's step two? Let's change the color. Oh, that is not what I wanted. So step two. Okay. Step two, we have to um, write down what's given in an equation. So write down what's given. Okay. So this will help us give us direction in our problem, and it'll help us see a roadmap, kind of like a guided path on how to solve this problem. Okay, so what's given was 2.7, so we're going to write down 2.7 moles of carbon, and we always put that over 1. Okay, so write down what's given over 1. Whoops. over 1. Okay? So that's our second step. Our third step is to develop our mole ratios. Okay? Develop our mole ratios. So in order for us to develop our mole ratios, we need to know our two compounds. Okay, this is very important. We have to know what our two compounds are. Okay, typically in these problems, they're going to give us two compounds in the problem statement. So notice here, we have first compound CS2. Okay, so we look for this CS2 in our balanced equation. And we could see that CS2 is right here. And then now we want to look for our other compound. And notice here they give us carbon. Carbon, we could also find, well, that is a wonky arrow there. Okay, moles of carbon. We look carbon up. Oh, carbon is right here. Perfect. Okay, so now we develop a mole ratio out of these two compounds. Remember the mole ratio, all that we're looking for, okay, all that we're looking for in a mole ratio is at the coefficients, okay? We only look for the coefficients and we utilize those for the mole ratio. Remember, the mole ratio is a fraction, okay, guys? It's always a fraction. So the fraction that we develop here, our 5 moles of carbon from the balanced equation, because there's a 5, and since there's nothing here, we have to assume that that's a 1. So we have 1 mole of CS2. That's it. That's the mole ratio right there, guys. Okay, that's all you have to do. You look at the coefficients. Okay, the next step though, or next part of this step, we have to see if the ratio fits. Okay, so ask yourself, does the ratio fit? Okay, so we have to look if our moles of C could cancel if we put this in there. Okay, so if we were to put this right here, would the moles of C cancel? Would this cancel with this? Correct. That will not cancel. Okay, guys? So in that case, we have to rearrange our mole ratio. Okay, so what we have to do is we have to flip these guys. Okay, so do a little flipperoo there, and then we get 1 mole of CS2 over 5 moles of carbon. Okay, so this gives us the correct expression to put in for our problem. Okay, so then now what we could write is 1 mole of CS2 over 5 moles of carbon. Now if we did this correct, we could see that moles of carbon cancel out. Okay, then the next thing that we do is we calculate. Okay, so there's two ways you can do it. You can either do it by hand or type it in your calculator. So what I would do is just simply do a calculator. Okay, so we get 2.7 divided by 5. Okay, remember it's 2.7 because we have this 2 right here in the numerator, 2.7 in the numerator, and we have this 5 in the denominator. So this ultimately turns into 2.7 divided by 5. Okay, that's what this looks like. And this is moles of CS2. Okay, just showing you how we go from these two fractions right here to a one fraction, and then we can enter this in our calculator. So 2.7 divided by 5, we get 0.54. So overall, we get 0.54 moles of CS2. So what you get at the end for the units should be what we were looking for in the beginning. So what were we looking for? It is circled. We were looking for moles of CS2. Is that what we were left off with? Yes, we were. Okay, guys. So this is the steps necessary to do these problems. Okay. Of course, some of these steps could be written down or completed at an earlier stage, or some could be omitted. But please stick to these steps in the beginning until you get more confidence in completing these problems, and just feel more comfortable. Okay, guys, if you have any questions, please let me know, and have a good night.